Hello students, welcome to the first episode of our example problem series for Circuit Analysis 1 here at NDSU. This first episode is going to be about circuit components, electrical quantities, as well as Ohm's law that relates all of them together. We see here that we have a simple circuit with a voltage source and a single resistor. To begin our analysis of the circuit, we first need to understand Ohm's law. When I was learning circuits, we had a handy little relationship that we could draw using a triangle, just like this, with voltage at the top, current and resistance at the bottom. If you memorize this, you'll be able to derive any of the relationships that Ohm's law gives us. If you cover up one of the quantities and look at the other two, you'll be able to come up with the expression for the quantity that you covered up. So, if we're going to solve for voltage, let's cover it up and look at I and R. Treat this vertical line as multiplication and this horizontal line as division. So V equals I times R. Alright, so in our circuit, we have a voltage and we have a resistance, but we don't have a current. Conventional current tells us that it flows from the positive node of our voltage source. So let's draw that. This current is flowing all the way around this circuit, but I'm only going to draw the arrow up top just to keep it clean. Okay, so let's try to solve for what I is. Let's cover it up and look at the other two quantities. V divided by R is going to give us current. And we have those values, so let's go up here. I in this circuit is going to be 10 volts divided by 5 kiloohms. That is going to give us 2 milliamps. There's 2 milliamps flowing in this circuit. And it's basically solved. We have all of these simple electrical quantities, I guess, except for one. Let's take a look at power. Power is the current multiplied by the voltage. Now, since we have such a simple circuit, I'll tell you now that a resistor is always going to absorb power. It'll never deliver any sort of current or voltage because of its nature. It absorbs, it hinders current. It could be this 5K resistor might be a light bulb, perhaps, where it would dissipate power and produce heat and light. So we now have the current and we have the voltage. Let's solve for the power that's going to be dissipated through that resistor. 2 milliamps times 10 volts is going to give us 20 milliwatts. And we could say that since it's a resistor, it's going to be 20 milliwatts absorbed. We can also solve for the power delivered by this voltage source. It's going to be the same thing. P equals I times V. I being 2 milliamps flowing through that circuit times 10 volts being delivered by that voltage source, 20 milliwatts delivered. All right, thanks for watching.